Now we have an extension of sequences. We are looking at sigma notation. See that Greek letter sigma? And that's going to talk about the sum of the terms of a particular sequence. So whenever you see this notation, there's a few things you want to be careful about. I've already reworded it in terms of typing, but the sigma, that stands for sum. And you want to figure out, well, how far should I go with the terms of the sequence? The first thing is they're giving you the general term, which is located in the argument of the sigma. And then you're saying, well, how many terms should I take? Well, we start at term number 1 with I equals 1. And we end at term number 7. That's located by the number on the top of the sigma. So once you kind of learn the pattern of this particular notation, it's a lot nicer to write it this way than having to write out, find the sum of the terms of the sequence, a sub I equals I plus 1 over I plus 2 with I going from 1 to 7. That's quite wordy. And it's really a convenient way to express this. Now we're so used to using a sub n or a sub x. The only reason why they're using I is because you kind of already use the n everywhere. So we'll keep, I, j, and k available. But you can use any variable you'd like as long as they match. So I don't know if you can see it, but we use i's. And so notice the notation at the bottom will indicate how you're using this variable. So we're going to evaluate this by hand. A lot of the techniques maybe you see in your future math classes, it really helps to be able to write out the first few terms of the sequence just by hand without needing any sort of calculator. So starting off, as far as a sub I is concerned, I can start you off with notation. If we're looking at the sigma notation for this general term, a sub I, really what we're looking at, what is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6 plus a sub 7. So notice we're starting at 1. So that's a sub 1. And we're ending at 7. We see a sub 7. So now it's a matter of computing the terms of the particular sequence. So I'll take it where I'm kind of showing this all at once. But if a sub I is I plus 1 over I plus 2, pretty much you're plugging in for whatever term you see as the subscript. So here for the first term, a sub 1 is 1 plus 1 over 1 plus 2. Separate this by a plus sign because we have the sigma notation. A sub 2, we're taking the general term, the stuff that doesn't change. And here, if we're looking at this, I'll alternate, I'll say green. We're plugging in 2 wherever we see the variable because they're both I. Add a sub 3. So remember, the general term, we have constants that we're adding. But this time we're going to plug in for I, that's 3 for both of them. Plus, we have a sub 4. So that will leave us with, let me write it out. I have a plus 1 over a plus 2, but that means we plug in I equals 4. Now we have a sub 5. Again, a plus 1, a plus 2. This time around, we're plugging in for 5. So 5 plus 1 over 5 plus 2. Almost there. I believe we have a 6. So we have plus 1, plus 2, and then we're using to plug in for I. We should have a 6 in each case. And finally, a sub 7. I have a plus 1, I have a plus 2, and I am plugging in 7 for the I. So now we kind of have a representation of all the particular terms. They're all separated by plus signs. That's what summation means. And so now it'd be your job to just simplify the numerator denominator. So you're going to get a fraction. So 1 plus 1 is 2. 1 plus 2 is 3. We're adding that to 2 plus 1 is 3. 2 plus 2 is 4. Adding this to 3 plus 1 is 4. 3 plus 2 is 5. Adding this to 4 plus 1 is 5. 4 plus 2 is 6. So there's some sort of pattern going on. Adding this to 5 plus 1, which is 6. 5 plus 2 is 7. And sometimes you may even start seeing the pattern within the first 4 terms, so maybe you don't have to keep plugging in formulas. But I like to be careful when I'm first starting off. 6 plus 1 is 7. 6 plus 2 is 8. 7 plus 1 is 8. 7 plus 2 is 9. So pretty much we want to find the sum of all those fractions. Now, feel free, if you're interested in doing this by hand, you'd have to find the LCD of all of these numbers. But remember, we have a nice tool at our fingertips. We have our TI that actually adds fractions. So what I'll do is I'll switch over really quick. And we're going to enter this in our TI just in the home screen. So how do we enter fractions? So you could do it either way. You can use your alpha key to actually see the fractions, but I'll kind of go shorthand. I could say 2 divided by 3, 2/3, plus 3/4, 3 divided by 4, plus 4/5, 4 divided by 5, plus 5/6. And notice I'm being careful to eye what I've written down in my work because it could get quite scary. So now we're on plus 6 divided by 7, plus 7 divided by 8, and finally for the 7th term, plus 8 divided by 9. Now before you press enter, you may want to see, you can press enter. Sometimes you get a decimal answer and it doesn't quite look doable, but always check to see if you can change this decimal answer into fraction form. Kind of depends on your directions. Sometimes if they allow you to use a decimal form, they'll ask you to round. But if they want you to find the exact sum, you want to see if you can change this to a fraction. So I'm going to press math. I'm going to press item number 1, fraction, and I'll press enter. And you notice that yes, it does become an exact fraction. Something that we probably would have a hard time doing by hand, but we have this TI at our fingertips. So I will copy over just so that I can see it. And we'll go back and kind of copy it off to the side so I can understand what I just found. And I know you don't always have this ability when you're drawing this in by hand, but the final answer that you would enter would be 14,291 in the numerator and 2,520 in the denominator. 2,520, let's make sure that's right. So that is actually converging to a particular number, which we had found it's around 5.7 or so. So that's how you do this by hand. Sometimes, it might go faster if you're working it out by hand, but sometimes when you have to find sums of fractions, it takes a little longer. Feel free to use the combination of the TI to help you in this particular course.